21ers, let's take a look at example 8. We're going to find another difference quotient. Here again, much like example 5, we have a polynomial. So the algebra that's going to be involved is a bunch of foiling and distributing, and then we should be able to cancel the original function. Like whatever's in this position should cancel out with some pieces from f of x plus h is kind of a bit of a green flag that we're doing something correctly. So instead of doing the side hustle where I find f of x plus h and I find f of x separately and then I subtract them, I'm going to kind of streamline this because we are to example 8, right? So let's see if I can streamline this a little bit instead of breaking it up piece by piece. So let's find f of x plus h minus f of x in ratio to h. So if I want f of x plus h, that says put an x plus h here, 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 and see what shakes out. So let me go ahead and put a pretty large fraction bar. So for f of x, we'll have for f of x plus h, we'll have x plus h cubed, x plus h squared, x plus h, and a minus 9, right? And that is just f of x plus h. I need to subtract from that my original function, and I'll put it in brackets just to be consistent. So that would be x cubed plus x squared plus 2x minus 9. And that's all going to be in ratio to h. All right, and so eventually, I'm going to distribute this negative eventually, right? I'll have a negative x squared. Nope, negative x cubed minus x squared minus 2x plus 9. All of that should be canceling with something over here. And if it didn't, it's a bit of a red flag or a yellow flag to check your algebra. And if it does cancel, it's a green flag saying, hey, great, keep on going. All right, so now, oops, I scooched that a little bit too much. There we go. So I'm going to go ahead and put an equal sign. And there's going to be a lot of algebra here. Now, if you've distributed this before, great. If not, I would say just practice. And I'll put a little side note here, right? If you have x plus h cubed, it's x plus h times x plus h times x plus h. And what you want to do, you want to multiply these two together, then you want to distribute it, right? So what I mean by that is if I multiply these two together, I'm going to have x squared plus 2xh plus h squared times another x plus h. So what you'd have to do is you'd have to take x squared to x and h, right? And then I have to take 2xh multiplied to x and h, and then h squared multiplied to x and h. Or you could think of it the other way. You have to distribute the x to the x squared 2x and h squared, and then you have to distribute the h to the x squared 2x and h squared. Somehow you'll have to distribute that and collect like terms, and I would recommend practicing that. But I'm going to tell you, I have done x plus h cubed so many times that I actually have it memorized. So this is x cubed plus 3x squared h. Ooh, I forgot the squared. Plus 3xh squared plus h cubed. All right, and x plus h squared is x squared plus 2xh plus h squared. And then I distribute the 2 to the x plus h to get 2x plus 2h. I've got a minus 9. I'm going to distribute that negative to my entire original function. That is a weird looking 9. Let me clean that up a little bit. And I have that all in ratio to h, right? So a lot of algebra. Now let's check that my original function canceled. So if I look at negative x cubed, I did have a positive x cubed. Great. If I look at negative x squared, do I have it anywhere? Oh, I do, right there. Good. So that's going to cancel. Let's look at negative 2x. Do I have a positive 2x anywhere? There it is. All right, those cancel. And then I can see the 9, right? The negative 9 and the 9 cancel. So that is all green flags, right? So there's some algebra that's canceling out. That is a good sign. So let me just collectively kind of see what's left, because these can get so messy. So we have what? 3x squared h plus 3xh squared. I got an h cubed. It looks like I've got a 2xh. I've got an h squared. I've got a 2h. And then this is all in ratio or in fraction in quotient 2h. So a lot of times, and it's going to happen here, is every term in this numerator has an h in it. So let me factor that out. So I'm going to have h times 3x squared plus 3xh plus h squared plus 2x plus h plus 2 all over h. This is going to cancel. So ultimately, my endgame answer is 3x squared plus 3xh plus h squared plus 2x plus h. Oops, just kidding. They should have a squared, huh? No, wait. Gosh, I want to make sure. No, this should not have a square on it. I just wanted to check that my algebra is correct. My bad. Plus h plus 2. All right. So there we go. All right. Bunch of algebra, but the green flags were that my original function canceled out, and then another green flag is that you had an h common to each of these terms up there. That's a pretty that happens more often than not when you're dealing with a difference quotient with polynomials. Those are pretty common parts of the problem where, like I said, the original function cancels out and then you can factor that h out of the numerator. All right, thanks so much. Bye.